Hello. So we're continuing on with functions this week, and one of the questions I had is what is the difference between a math function and a programming function? And that's a great question. It's also a really tough one to answer because it really depends on the type of programming language. We have certain programming languages called functional programming languages versus what Python is, which is an imperative programming language, and the functions work a little bit differently and actually maybe closer to what we think of as mathematical functions. But what I'm going to do is try to give you a little advice on how to think about functions when it comes specifically to Python. So we have a mathematical function, something like f of x is equal to 3x plus 1, and we have some inputs, and the input is going to be the x value because the function is a function of x, and there's going to be some sort of output. If we input 2, for instance, we're going to get 7 out, and this is the way mathematical functions work. And a Python function can work this way. We could have define a function called fx or bob or function 12, whatever we wanted to call it, and we could give it a parameter of x, an input of x, and then we could return some sort of calculation, some sort of that depends on the input, right? So we could say 3 times x times 1, which if we input 2 would be 7, and then we're going to return that value. So in that sense, we can create a function, a Python function that would perform the input-output operations that you would need to solve a mathematical function. But this is also a Python function right here. Got to have some parentheses. That would be a syntax error. Sorry, my drawing is not the greatest, but all right, those are parentheses. So this is a very poorly drawn function called my function that doesn't take any parameters whatsoever, and all it does is return hi. So in that sense, this really doesn't take any sort of input. We don't really calculate anything. It returns hi, so that is some sort of output. But honestly, I could have just printed hi. I don't even need to return anything from this function, although the default value of none would technically be returned. It returns a null value. But in this sense, Python functions don't always act like a mathematical function. My advice is the best way to think about functions in this course, specifically for the Python 3 programming language, is we're just going to think about functions as ways to organize our code. It's really just a block of code, and it can take inputs, but it doesn't have to. It's going to do a little job for us, and then it's going to maybe have some output, it maybe not. It may have no output except for the null value none. But what it is, it's a block of code that does a job. So that's what a function is in Python. It's just an organized little block of code that does a job for us. And that job could be to perform a calculation, that job could be to print some statements, that job could be to process a list or do something to a string, to search some sort of iterable structure besides lists like dictionaries or sets. And do a job for us. And the reason why functions are so important in programming is that when we think of modern applications, they're very long. I mean, a short program, that we'll write in this class, maybe, 20 lines of code. But if you're talking about an application like Microsoft Word, that's a million lines of code, easy. So when you have a lot of code, you need to be able to organize that code into smaller pieces for maintainability, to be able to modify it, to be able to fix things when you find things that are broken. So really, that's what we're going to do with functions in Python. We're just going to organize our code into different little mini programs, little blocks of code that then will interact with each other. So I hope this helps you think about the difference between a mathematical function and the functions we'll be using in this class. Let's briefly revisit naming conventions in Python because just like we had to name our variables, we might have num1 is equal to 25 or some sort of input that we've cast as a float or an integer. We also name our functions, and functions in Python have to follow the same rules as variable names do. So we can't use any Python reserved words. So print is a reserved word in Python, so we can't name our function print. Input already taken, can't name our function's input. We're going to learn about all sorts of other words, if, else. All these are taken already by the Python language. So we can't name our functions, we can't name our variables, anything that's already defined within the language itself. In addition, we might be importing some stuff. So we could be importing math, we could be importing turtle. These are really files. This is math.py and turtle.py. So we don't want to name our files math or turtle if we plan to import them. And we don't want to use the names inside of any of these libraries that are already used. So for instance, math has a POW function. So if we're going to import math, we don't want to overwrite the math POW function that we've just imported, so we can't name our functions POW. So when in doubt, just don't use any names that sound common. They're probably already taken. Print's going to be taken, input's going to be taken, sum is going to be taken. But with whatever language you use, whether it's Python, C, Java, whatever, you have to become familiar with what's already been taken, what you can't use. And then when you're naming your functions, you're naming your variables, you're naming your files, you don't want to use any names that are already being used. So let's work through an example together. We're going to make a simple calculator, but we're going to organize our code into functions. For a program this simple, it's not very many lines of code, you wouldn't have to use functions to get it to work. But we're going to organize it into functions so that it makes the code easier to expand, to add things to modify in the future. So our calculator is going to be pretty simple. It's going to take two numbers from the user and then return or print, let's be clear with our words, print for the user the multiplication, subtraction, addition, subtraction, multiplication, and division of the two numbers. All right, so let me show you how you would write just it without any functions at all, right? So we've got num1 is going to be a float. So we're going to take two numbers from the user, input, enter the first number, num2, float, input, enter the second number, and then we really just have, four print statements. We would say num1 comma plus num2 comma equals. So this is just telling the user, what it is we've done, what we're giving them in this statement, right? And we're going to say num1 plus num2. And let me just show you, and we could do a print statement for each of the subtraction, the multiplication, and division. Let's show you how this works here. We enter the first number 3, 4, 3 plus 4 equals 7. So this is a short program. Like I said, we really just need 3 more print statements and we're actually completely done with what we want this to do. But this program could become really big. Maybe we keep adding to it and we want to make it more fancy and exciting and add turtle and add more functionality. It's going to be really hard to add to just written like this. So organizing it into functions is going to allow us to have a lot more control over this program and to be able to modify it and add to it in the future. So for the moment, I'm just going to get this out of our way, but let's save it so we can cut and paste. And we're just going to comment this out and we're just going to ignore it. All right, we're going to think instead about this program and how we could organize it into functions. We want one function, one job. So each function should have one job. So let's make a separate function for adding two numbers together, and a function for subtracting, a function for multiplying, and a function for dividing. And then we're also going to have a main function that's going to use these helper functions to get our input, call the functions, and print those out for the users. So let's go ahead and start creating these. So we'll say add2. It's going to be the name of the function and it's going to take two numbers. All right, and I'm going to use the keyword pass. This allows me to run, even though this function doesn't have any code, this lets me run it so I can check the syntax for all my headers. So this will be add two numbers. It's always good to, again, your functions will not always be this simple that, so you want to have some code to tell anyone who's going to take a look at your code what your function is supposed to do. So subtract two numbers, and we're going to say def sub 2 and 1 and 2, and again we'll just pass. All right, we'll say this is going to multiply two numbers, and we're going to have def mult n1 n2. This is the name I gave the parameters for these functions. We've got divide two numbers, def div n1 n2. All right, and again pass. Now our main function is going to get user input, call helper functions, and print values for us. And we have to define main. Main is going to take nothing. In Python, that's normally how I write Python code anyways. You may see other Python people. If you run Python at the command line, which I do sometimes, it's kind of neat sometimes to get your main function to take parameters right at the command line. It can be really convenient and make things a little quicker if you're running through certain types of projects and stuff. Other languages like Java always takes a parameter at main. Main always runs first. It always has an array of values that can come from when you initialize and when you run the program. So you can have parameters in here. You may see that in other languages. You'll see me in all my examples for this course in particular because we're not using the command line. I usually won't have anything in main. So again, I'm just going to pass this, and what this is going to allow me to do, I'm going to get rid of some of these extra spaces I put in. What this is going to allow me to do is to go ahead and print or to run this code and just double check my syntax that we have our parameters. We want to have commas between our parameters. We got to have a colon. We have to spell the def keyword correctly. We have to use Python rules for naming our functions. So I can go through here and I see I didn't get any syntax errors. So all of these are written syntactically correct. So now I can go through and actually code up my helper functions. And you can do it either way. You could write all your helper functions first and test them out as you're going, or you could write your main function first and just put dummy values in your helper functions and test it that way. And I'll show you both ways as we go through the class. In this case, I'm just going to go ahead and write our helper functions first. They're pretty simple, and then we'll write up our main functions. But in other examples, I'll show you different ways of doing it. So here we could have some variable, we'll call it total, and we're just going to add n1 and n2 together, and then I'm going to return that. I'm going to return that total value. Subtract is going to work just about the same way, but I don't actually have to do this if I don't want to. I could just return this calculation. That can save us some code, and it really depends on if you need the value somewhere else, whether or not it's worth saving it into a variable. In this case, it's not really necessary, so for the rest of my functions, I'm just going to return n1 times n2. And here for dividing, I'm going to do the same thing. Return n1 divided by n2. And now I'm going to go ahead and run this just to make sure I don't have any syntax errors. Nothing happened, so I'm good. I didn't get any errors. And now I'm going to use my main function. I'm going to go ahead and test these. So let's do a print of the function call. And I should call these. I doubt there's anything called multiply or mult or div, but just in case, I'm just going to call those 2 for two numbers, right? So let's print a call to mult2, and let's send it 3 and 5. And if I were to run this right now, and I'll show you what happens, I get nothing. Because all I've done is define all these functions. I haven't actually run any code in the sense of I haven't called a function. I've only defined them. So I'm going to make a call to main right here, down here outside of a function. I'm going to call main. And so what's going to happen is we're going to start up here, define, add to RAM, define, add to RAM, define, add to RAM, define, add to RAM, define, add to RAM. And then I'm finally actually calling this main function. So this code will actually get run. And then we've actually called the mult2 function, so that's also going to be run as well. So when I run this, in this case, I sent it 3 and 5. 3 times 5 is 15. So we see that this works, and we've managed to run this function. So now this code I can actually, let's uncomment it. I can actually take this code, because this is pretty much, oops. I hit Control Z instead of Control X. Let's uncomment that and let's do the right command. There we go. And I'm going to put this inside here. And I'm going to get the numbers from the user, just like I did when I wasn't in a function. I'm just going to grab the first number, the second number. I need to cast those as a float. And then here, though, instead of adding those numbers directly, I'm going to make this call to add 2 with num1 and num2. And some of you might be panicking a little bit right now and saying, oh no, you called it num1 and num2 here, but it's called n1 and n2. That's fine. So remember, you should have read about in your book about local and global scoping. We're only going to deal with locally scoped variables. So here, whatever we send it is called n1 and n2. This function, this function, this function has no idea what num1 and num2 is. Never heard of it before. We're actually going to send whatever value is in num1 and num2, and it's going to be saved in n1. Value in num2 will be saved in n2. We're just passing around the values, just like we're mailing letters around, right? We're saying, hey, I've got this value in my num2, you put it in your n2, and that's what you're going to call it in your function. Down here, I call it num1 and num2, but you don't care about that. Main has no idea what n1 and n2 was, never heard of it before. That's fine, because all it cares about is the value that gets returned from total. Doesn't care about what total is called, never heard of it before. It's just going to actually be printed right here. And we could save it in something if we wanted. We could say t is equal to, and let's leave this. Okay, so we've got our add to. We could say t is equal to the call of sub2 with num1 and num2, and then instead of actually putting that function call in the print statement, what we can do, let's copy this. So we're going to say minus here. Num1 and num2 is just t. So both of these are perfectly fine. If you want to, maybe you need that somewhere else and you don't want to keep making function calls, you can just save that into t and use it multiple times. So we're going to have 2 more print statements that we need before our program is complete. We need to do our multiplication, and we need to do our division. Make sure we have the right, this would be a logic error if I left it as plus. The computer doesn't care, but it's going to look funny because I'm going to change this to mult2, and I'm going to change this to div2. So now what we should do is be able to get our input from our user, and then we're going to print the results in a nice, attractive way that the users can understand. So we're going to enter, let's say we do 40 as our first number and 10 as our second number. We print it out for the user. 40 plus 10 is 50, 40 minus 10 is 30, 40 times 10 is 400, and 40 divided by 10 is 4.0. So it's like I said, so this is a pretty simple program, but what's kind of exciting about it is as we learn new things, we're going to learn loops, we're going to learn if statements, we're going to be able to add to this calculator and make it do cooler, more interesting things besides just adding and subtracting and doing everything and presenting it to the user. We can give users choices, we can validate their input. So as we learn more stuff in the class, we'll be able to have a more exciting calculator that can do more exciting things. So, all right, as always, let me know if there's anything else you'd like to see, if there's an example you would like me to do, or there's something you don't understand so I can make another video, and happy programming!